I'm Russell. You can find me at RussHWolf on Twitter or Slack. And I'm going to be starting next week at Touch Lab doing multi-platform stuff. We've just had a couple talks on multi-platform, so I'm just going to do kind of a quick intro with some of my thoughts. But in brief, the idea of multi-platform is to take common code and compile it to multiple targets. So that being things like JVM, JavaScript, Android, et cetera, et cetera, et cetera. And in addition to that shared common code, use platform-specific code to talk to any of the individual platform APIs. And the general idea here is making it easy to do the custom things when you have to, but share the things that don't need to be customized per platform. So the tools that let you do that, the first one, so what does common code look like? So it looks pretty much like any Kotlin code you write. So from Common, you have access to most of the standard library that you're used to, minus some platform-specific things. You can create classes, functions. You have things like the collections API. And when Common isn't quite good enough, there's various strategies for platform-specific code to be able to kind of create whichever implementation you need to interact with that platform. So you have things like expect an actual. So you can say, I expect some string that's going to be the platform, which you might call Android on Android, and you might call iOS on iOS. It's a very useful tool. You don't have to use it. So you could also just define an interface in your common and have implementations for it on each of the platforms. And a neat advantage to this is your implementations don't necessarily have to live in Kotlin. So maybe on the iOS side, for example, I want to have a Swift implementation of something that's defined in common. If it's an interface, you can still do that. And you have the ability to have multiple implementations. So expect an actual, the compiler enforces that they are one-to-one per platform. So there's exactly one actual declaration for every expect declaration. If you wanted to be able to do things like substitute mocks for testing, interfaces are a lot more flexible. So that's kind of a brief overview of multi-platform. How did I get into this stuff? So I did a project in React Native a while ago, about 3 years ago. So my day job, I mobile consultant. I build apps for different clients, and usually doing native Android, but we wanted to try out React Native and see how we felt about it. I wasn't a very big fan, but it got me thinking a lot about what would I like in a multi-platform framework, or in a cross-platform framework. And around that time, that was around when the very, very first version of Kotlin Native came out. So that was before you could share anything to it, but you could kind of see what JetBrains was starting to build towards. So I was watching that out of the corner of my eye for the next kind of year or so. And one day this happened. So in version 0.6 of Kotlin Native, they added multi-platform support to it. So this was finally the moment that if you'd been kind of using Kotlin on the JVM for a while, you could start to experiment with sharing some of that code to the native platforms. So I started messing around with it a little bit. I did a couple little sample apps. And a couple months later, the next Kotlin version came out. Had a bunch of updates around the native threading model and stuff that I won't go into in too much detail. But there was this neat note deep in the changelog, and sorry if you can't read it, but exactly what it's saying is use the Gradle native dependency model to be able to publish klibs as Maven artifacts. So to translate that, it's saying Kotlin Native now had the ability to use the same kind of Maven dependency framework that you're used to on JVM Kotlin for native stuff, which means if you want to do something like write a library that runs on native, you have the ability to do that now. So I did. So I took some of the code that I'd been playing with in one of the sample projects that was interacting with the shared preferences API on Android. And I extracted out this little settings library called Multiplatform Settings. So what it does is key value storage based on native platform APIs. So initially that was just Android and iOS. I've since added a couple other platforms. And in addition to the kind of like raw wrapping of the platform APIs, there's also some nice Kotlin syntax helpers on top of it. So there's some operators and property delegates that let you get that kind of nicer enigmatic Kotlin syntax if that's the style you prefer. So it's available there on GitHub if you're interested in looking at it. And let's take a quick walk through kind of like the brief structure of what it is. So there's the core of it is this interface called settings that I'm just kind of using one method as an example, but it has a bunch of getters and setters for different data types. And it has different implementations on each of the platforms. So there's a Android settings, which wraps the typical Android key value API, which is called shared preferences. There's an Apple settings, which wraps the user defaults API, which is essentially the equivalent on iOS. Over time, I've added more platforms. So there's a JS settings, which wraps local storage and JavaScript. And there's other pure JVM implementations. So this one, as an example, wraps the Java preferences API. And I was talking a little bit about mock things earlier, so I also include a mock settings. So that means if you're kind of writing application code that interacts with this library and you want to be able to write tests around it, you can use this mock settings implementation, which just has a in-memory map, and you don't have to worry about serializing your actual data to disk in your tests. And then, yeah, there's some other operators and delegates and stuff to add that nicer syntax. So that's kind of the brief rundown of what the library looks like. So it didn't all start that way. So I'll tell you a couple stories of kind of things that I've learned along the way. So it's been about a year and a half since I first put that out, a little longer now. Yeah, I've learned a couple of things. So one of the big lessons that I think is applicable to a lot of people's kind of first start in multi-platform is the use of expecting actual versus the use of interfaces. So when you get a brand new tool, like you get a brand new hammer and everything looks like a nail. And the new tool in Kotlin Multiplatform is expecting actual. So the first version of settings was an expect class. Because like that seemed like what you do in multi-platform, right? And that was fine, like it works perfectly well. But you expecting actual is one-to-one, and so there's kind of no ability for consumers of that to be able to kind of supply an alternate implementation for things like testing or for other platforms or stuff like that. So eventually I kind of pulled out a interface on top of it to be able to do that. But I still left the expect actual in there. I don't remember exactly why I did that. It got kind of messy. There wasn't really any point to it. So eventually got to the point where it is now, where it's just an interface. You don't really need any expect actual there. For a little while, there was actually zero usage of expect actual in the non-test code at all. I've since added a couple more new ones, which I'll talk about later. But the overall lesson is just because you have that functionality there to use, you don't necessarily need it. And it's often the case that you can do things kind of a little bit more flexibly if you do it the old-fashioned way. So one of the first change requests, one of the first feature requests that I got after I put the library out was this question about what if you added change listeners? So the initial APIs were all just like getters and setters, but both the Android and iOS APIs also provide a way to listen for updates. So I started putting that together, or started kind of looking at what was there. So on Android, shared preferences has this listener API on shared preferences change listener. And it's basically a callback that it passes you kind of, every time something updates, it passes you a function that says this was the key that changed. But it does this funky thing where it says, it might get called again if there's repeated updates. So the documentation is kind of weirdly ambiguous about that. I don't actually know why. I think it's maybe behavior that kind of changed some from early versions of Android. But anyway, iOS exposes a very different looking API where they have the NS Notification Center, which is essentially a centralized event bus that lots of different system updates go through. So when a user defaults update happens, you can subscribe to that and you get this user defaults did change notification, but it doesn't tell you anything at all about the change. All it tells you is that a change happened. So I have these kind of like two very different APIs and behaviors that I'm trying to like write a shared interface around. And what I came up with looks like this. So I'm omitting a bunch of the kind of glue code, but the core of it is I keep a cache of what the kind of previous value at that key was. In all of my callbacks, I check if that has changed and only update the user-supplied callback if it did. So it behaves a little bit differently than either of the platforms, but it does so in a way that I could synchronize the behavior of both platforms. So I put that out, and that was all right for a little bit. And then I added that JavaScript support. And then I had the same problem all over again. And it turns out, the local storage APIs do provide ways to listen for updates, but they're basically built for talking to other processes in other windows. And I haven't yet found a way to kind of make it work in the same way that the Android and iOS notifications do, so I'm kind of just in trouble. So where I landed with that was I split the interface. So I have a observable settings interface that holds all of the listener APIs, and like Android and iOS implement that. And the base settings interface, JavaScript just implements the base settings interface. So you can, in your common code, check whether you're just a settings or you're an observable settings and only interact with the listeners when you are observable. So another fun developer story was around JVM implementations. So early on, I put out a call saying, what are other platforms that I should wrap around for this? And someone suggested properties on the JVM. So that seemed nice. So properties are a Java API that reads things like the Gradle.properties file that you might know of from if you're used to using Gradle projects. That's just kind of like a standardized file format that the API can read. So I put an implementation out that wrapped that. And then I got this pull request that pointed out something I'd missed, which is the Java Properties API doesn't actually do any work for you to serialize updates to disk when you make changes. So this pull request is essentially adding a callback inside of each of the change calls so that you would get the same behavior on the properties implementation that you do on the other platforms. Just as I was about to merge that pull request, I got this other comment that said, hey, by the way, there's this other API called Preferences that basically behaves the same way as the Android and iOS ones do and does exactly what you want, and plus the properties didn't have update listeners and this one does. So what I ended up with is now I have two different implementations that I'm maintaining on the JVM, which means like if you're using this in a project that has a JVM target, whichever API you want to interact with, you can. And one of the lessons I came away with that is like there's a lot of complexity to having lots of different platforms that I don't have as much experience with. But another thing I thought about is it is actually important to have that flexibility. So someone kind of introducing this library, like introducing multi-platform into their project that has a JVM target might be using lots of different things to do their existing key value storage. And the more things that my library can interop with, the easier it will be for them to use this library to kind of add multi-platform support to their code. So another fun thing I did recently was adding CI support to the library. So excuse me. So right now I have a setup that's using Azure pipelines to be able to build on Mac, Linux, and Windows hosts, which you need to be able to target every single one of the native platforms. And one of the neat things that this enabled is building the common code, so things like the settings interface to every platform. So previously, I was building everything locally, and I was just building the platforms that had implementations, which means if you, as a consumer, want to be able to use it on a different platform I hadn't thought of, you don't have any opportunity to do that. So now the interface exists everywhere. You still have to supply the implementation if you want to use it on a new platform, but you have the flexibility to do that. And there's a funny little trick in the Gradle code to make that happen, where the Kotlin Gradle plugin gives you this list of native presets for each target, and you can just kind of iterate through them and say, I want to build a target for each one of these, because there's not a built-in that just turns it on for everything on its own. And one of the couple things that came out of that is there's a bunch of new Apple targets that have been added in the most recent Kotlin version. So originally, I just had support for ARM64 and x64, which is the 64-bit device and simulator. I eventually added like desktop support and 32-bit iOS, but now there's all these new targets that would have been a pain to sorry, what was I saying? Yeah, they're just kind of like a lot more to manage, and it's nice to kind of have some CI in place to make sure that it's all working the way expected to. And it's a good thing I had that, because I actually learned that my initial 32-bit implementation was not doing what I thought it was. So the user defaults API that these things are running under the hood has this set integer call, which is using the integer size that is native to the platform that it's running on. So it might be 32-bit or it might be 64-bit. And initially, I was just using this convert function that Kotlin Native provides to kind of try to convert between those. But it turns out that will let you essentially cast between 32 and 64-bit things, so between int and long in Kotlin. But it won't, that doesn't allow a system API that's only storing things as 32-bit integers to store anything larger. So the long APIs on 32-bit systems were not actually working. And I didn't realize that until I had all that CI in place and was running the test on a 32-bit simulator, which I didn't have until watchOS came along. So where that's ended up is now I've reintroduced some expect actual to the library. I have this set long extension, and there's kind of there's a set long, get long, setting, get int that has different implementations per platform. So on 64-bit platforms, it can just put both ints and longs into integers, or sorry, into iOS integers, which is 64-bit, which is essentially the same as a Kotlin long. And then on 32-bit stuff, I have to stringify it. So it's not super elegant, but it does the trick, and it can still serialize every possible value correctly. So some other notes from other things from other kind of things I've learned along the way. An important thing for library development is that Kotlin Native currently, because it's still in beta, has no version compatibility guarantees. So there is, so it's there's this kind of ratchet that happens every time a new Kotlin version comes out, where you're no longer compatible with, when you update your Kotlin version, your libraries need to update at the same time. So a lot of the library ecosystem will kind of try to update quickly so that you're not blocking all of your users. Another good note is the Gradle setup for a lot of this stuff can get kind of complicated. There's a good multi-platform Gradle reference here that's been, for a long time, a lot of the multi-platform documentation has not always been kept up to date very well, and this page has always been consistently pretty accurate. And a good just kind of reminder, so I've talked about a lot of difficulties and issues and things, but things have gotten a lot better over the last year, and they will continue to over time as the ecosystem matures. So what are some other things I'm working on? I always like to shame myself into, I need to do a Maven Central deploy right now is just deployed on JCenter. And I just hate dealing with publishing config and stuff, but it's been on my to-do list for a while, and it's still there. I have pull requests up right now to do coroutines flow and Kotlin serialization integrations. So probably we'll have that in the next version, but it's up on GitHub now if you're interested in looking at them. I'd like to get it set up for on-device unit tests so that I can test some of the platforms that aren't currently being tested in CI. And then also like add some more implementations. So like there's a pull request right now that's a draft trying to add Windows registry support for Windows implementation. And I'm interested in getting feedback on like what a useful API to use on Linux would be, because I'm not aware of one right now. So what other stuff is out there? So not going to go into much detail on these, but like JetBrains has a bunch of libraries that they've been working on. These three big ones are like coroutine serialization and the KTOR client essentially give you like your default HTTP stack in Multiplatform, which is pretty useful. And there's some of the things that they've been working on. And then the community has been putting out some libraries. So one of the notable ones is SQLite, which gives you SQLite access in your shared code. And there's a couple other community libraries there as well. And maybe at some point yours. So one of the things I want to do in giving talks like this is try to inspire more people to get into this ecosystem and think about what that would look like. So one of the kind of strategies you can use to try to do this is wrapping around platform APIs, which is what the kind of core of multi-platform settings does. So like there's an implementation that's already there and you're just going to create a shared interface into it. So like a lot of the hard work is done, but you have to do the kind of extra work of taking whatever different platform API or whatever different platform implementations there are and find the shared interface around them. Or you can go the other way. You could write something that's pure Kotlin. Maybe it's like NAP utilities or something like that. The work there is creating something brand new, but once you have, you get this great payout where now you can access everything. Like once that common Kotlin implementation is there, there's no work to add more platforms to it. But either way, like now is a really great time to think about doing this. Things have been maturing over the last couple of years, but it's still a very young ecosystem. There's a lot of opportunity if you want to start contributing to open source to be the first person to build a thing on this platform. That was one of the things that inspired me to get into this stuff to begin with. And if that's interesting to you, I recommend you think about it. So thanks. Here's some links if you want to refer back to them later. So the link to the library code is there, that Gradle documentation page, and there's a repository at the bottom that has a good list of libraries that are already out there that might give you some inspiration. And then, as I said earlier, I'm joining the team at TouchLab, who are kind of taking a pretty big leading role in building a lot of building multiple apps for clients and kind of defining best practices and things. So if you are interested in that, or you want help kind of getting started with stuff, let me know. So thanks a lot.